the gentleman on the stage, Mr. Saurabh Nikhare. एक बार जोरदार वाली तालियां हो जाए for the last session of the evening. Thank you.
In every corner of our modern world, coating solutions play a crucial role in shaping every aspect of our environment. And innovation is what drives the coating industry forward, as customers increasingly demand for novel, sustainable solutions. At Brenntag, we are committed to supporting the coatings industry and staying at the forefront of technology and market trends. Focusing on rheology innovation, customization, and training, our Innovation and Application Center in Mumbai, India, is a dynamic hub for crafting new concepts and prototypes that consistently set industry standards.
Our comprehensive portfolio of rheology solutions caters to diverse categories and segments. Whether you require architecture paints, inks, industrial coating, coil coatings, wood coating, or many more, we are ready to assist you in reducing cost and improving product performance. We conduct a holistic spectrum of technical activities, including prototype creation, detailed rheology analysis, and solvent handling. We also perform spray booth application, technical troubleshooting, benchmarking, and stability studies. With this Innovation and Application Center, we are always ready to transform ideas into market-ready, cost-optimized, and high-performing products for our customers and partners in South Asia and beyond.
Our dedicated local team of experts also provide compliance support and in-depth market insights to identify new application opportunities. Being locally present enables us to create tailor-made solutions based on strong technical and market knowledge, ensuring fast-track development. We also manage local supply chains, offering a complete end-to-end service throughout the value chain. Experience technical support, innovation, engineering, and consultancy, all under one roof. We are an innovator in new products, a provider of sustainable solutions, and a partner committed to exceptional excellence. We are Brenntag, and we are dedicated to helping you succeed. Work with us to elevate your products to new heights and gain a competitive advantage in your market.
Hello. Good evening again. So this is the last session for today. So I will not hold you for long. I'm Saurabh Nikhare. I'll be speaking on the novel technologies for water inclusion in solvent-based alkyd enamels. So let's go through it. Okay. So the challenges that we are trying to solve at the moment, like of course there are solvent-based alkyd enamels are there, and they are first class solvent-based paints, and then we try to optimize the paint formulation. We try to control the VOC. Now sustainability, as you know, is the buzzword these days, and we try to minimize the VOC emission as far as we can go, and walk that extra mile, and then try to address this VOC reduction. The initiatives over the VOC reduction. So VOC regulations, they are there, but they are not stringent at the moment, I would say, in India. But going forward, as we are all aware that they are going to be in place, and we are going to face a lot of regulations coming in from the government itself, as in we need to control the CO2 emission, or say solvent evaporation, whatever way we can try to address. Okay, so and at the moment performance gaps are there between, say, water-based and solvent-based enamels. So when you move from a solvent-based enamel to a, say, low VOC kind of formulation, you tend to develop certain issues with that low VOC kind of formulation. So what are those issues and how we are trying to solve them? So we will take a deep dive over the issues or the challenges when we face when we move from a solvent-based enamel to a water included enamel. Okay, and third, so awareness on greener or sustainable products at the moment is a bit I would not say it is missing, but it is not there to the required level of mark. So so when we move from solvent-based enamels to water-included enamels, there is a certain loss of durability or finish, and how we can try to minimize it by having sustainable solutions that we are trying to discuss today. And need for innovation is there to deliver compliance and customer satisfaction. So basically, what we want to say is, you have a first class alkyd enamel, and when you try to develop a low VOC kind of formulation, then the problems what you face is separation. If you have not emulsified your system well, you have not emulsified your resin and solvent with water properly, then separation would come. Drying time, of course, moment you try to include water in the formulation, the drying time is going to increase. And of course, gloss issues are there, I mean gloss reduction issues are there, and L value. So basically L value, what we want to say is, typically for a white solvent-based enamel, when you compare that with a water-included enamel, so there would be slightly reduction in applied hiding. If you have not emulsified, the solvent-based system with water properly, then these issues can come, and these are the issues we are trying to, of course, other issues are there. I mean, bacterial growth kind of issues are there, or ink and corrosion issues are there. But we'll try to address the issues one by one. Okay. So what we were discussing earlier. So the third column, which is standard, this doesn't have any water, and you can observe gloss or spectral values as standard, or you can consider these values as standard. And moment you try to add water and go on adding water in the enamel, the gloss reduction happens. And it is still manageable when you go up to say 20, 25, 30% kind of water inclusion. But it goes for a toss moment you increase the water level above 35 or 40% or 50%. So there is drastic reduction in gloss, drastic reduction in applied hiding, and other issues are there. So we are trying to put the same thing in graphical format, as in for easier understanding. So the first graph on the left hand side, as you can see, the gloss values goes for a toss moment you add water, and the L value, as in the applied hiding, decreases. So the L value for a typical white enamel, it would decrease. Okay, that can be debated. I mean, say for a tinted enamel, or say slightly a darker shade, and if you have a cleaner surface underneath, then the tendency would be reverse. But what we want to address is, whichever way you want to take your L value, it would go reverse moment you start adding water. And drying time and separation, we have tried to quantify and put them in graphical format. Okay, now coming down to our additive. So we have a novel approach. So we have always discussed that polysaccharide chemistry is the market benchmark, that this technology works best when you talk about water inclusion in the solvent-based enamels. But earlier, many of the companies, they have tried to use emulsifier or a surfactant-based chemistry as an emulsifier for this water addition, and they have faced some challenges. So we went a step back, and then we tried to understand like what different surfactant chemistries are there, which earlier people have tried, and then they have faced some challenges that it is not performing to the level of a polysaccharide chemistry. So we did this backward integration, and with our supplier, we have developed altogether a different chemistry, which is a blend of different surfactants. So we understood that, okay, so a single surfactant molecule or a single chemistry would not work for water inclusion. We also want inclusion of 2 to 3 chemistries for water inclusion, as well as maintaining that added water, as in to address the separation, and at the same time not to hamper the other properties, say as in ink and corrosion and gloss reduction and everything. Okay, so this is about Sardebin WB410. We are discussing the product for water inclusion. So the name of our product, and Brenntag, though we are a distribution company, we would be doing this under our own branding, and this product would be manufactured here in India itself, and it's by appearance it appears as a white emulsion, but it is used as an emulsifier. It's not an emulsion, so it is used as an emulsifier to make the emulsion. Okay, so it's ionic in nature, dispersible in water, used for effective addition, blah blah blah. So many of the attributes are there, but what I would like to highlight is so we are recommending and trying to discuss and take this up with alkyd enamel manufacturers, as in for best way of addition of water in alkyd enamels is by making emulsion intermediate. So that is the way we are trying to promote this product, as in you take water, whatever amount of water you want to add, and then you mix this additive in the water and then make an emulsion intermediate. How to do that, what are the nitties and gritties of doing that, and adding water in the solvent-based enamels, we'll further discuss in next slides. Okay, so this is the typical emulsion intermediate formulation we have used, and for designing, for finalizing the quantities of say alkyd resin, solvent, antifoam, and this additive, we have tried our best not to touch the resin part, as in the resin part of your formulation would remain unchanged. Only the MTO or the solvent part would drastically decrease, and that would be replaced by water. And we, as I said, we are promoting this additive for making emulsion intermediate. We encourage people to make an emulsion intermediate, not to add water directly, as in you complete 100% formulation, you add this additive and then add water. That can also be done, but that's not the perfect way or ideal way, I would say, to add water into the solvent-based enamels. Okay, some details are mentioned, like what are the processing conditions, what are the, the processes you need to follow while addition of water. So, so many of the customers, they asked us what is the rate of addition of water, and then we say, sir, 3 liters per minute, 30 liters per minute, 300 liters per minute. But that all depends on the size of your batch. How much is the size of your batch, and how much water you need to add. You just need to maintain a vortex while preparing the emulsion intermediate. Moment you don't observe any lump formation or the agglomeration kind of issues while preparing that emulsion intermediate, that would address, that would determine, that would finalize what is the optimum rate of addition of water required to make an emulsion intermediate. So we are trying to quantify in percentage, not in actual values, say liters or kgs per minute, but percentage. Okay, so formulation in detail, what we have used in our lab to prepare this alkyd enamel, and then compare this prepared enamel with the market available standards, as in checking the whatever properties, optical properties we have discussed earlier, how to compare those properties with this lab prepared sample. So this is the formulation we have used, and as I said, so standard is the one which doesn't have any water, and low VOC formulation is what we call that has emulsion intermediate. We have discussed it that we need to add water in form of an emulsion intermediate. So emulsion intermediate, how to make that also we discuss, and so this emulsion intermediate you need to add after grinding stage. So you take resin, solvent, dispersing additive, your pigments, you mill them, prepare your desired shade, and then add this emulsion intermediate, and then in the letdown you add the remaining additives, as in drying additives, whatever dryer mix you have, whatever anti-skinning additives or the remaining portion of resin or solvent you want to add, you complete the 100% formulation. So Brenntag has patented or developed a patented software called as CO2 Explorer. So we can try to help you and collaborate with you to quantify what is the CO2 emission of any of the processes or any of the raw materials what you are using in your production site. So that way, so typically for a manufacturer, say to a size of 10 metric ton per month, if we have a manufacturer whose production levels are to the tune of 10 metric ton per month, so he can go from existing 2,600 kg of CO2 emission to 500 kg. So that much reduction of VOC, we can try to collaborate with you and generate this data, generate this holistic data, so that you also can quantify what is your carbon footprint, what is your carbon emission. That way also we can try to collaborate, and this is nothing but a sustainability initiative, as we discussed in the beginning. So we are trying to address the harmful emissions, or trying to reduce the VOCs. So we can try to quantify that. So in this particular change, with this particular change, when you go from say 38% of MTO to around 8% of MTO, 2 plus 6, 8. So you observe 2,600 to 500 kg of CO2. Okay, these are the testing results with our additive and the competition additive. Typically, polysaccharide chemistry we have used as competition, and we have tried to quantify the drying time. Is there any impact? So we are not claiming that it would increase the gloss, it would reduce the drying time, but it would give the similar performance as in the polysaccharide chemistry. Okay, so these are the test results again. So the left hand side first picture, you see it's an emulsion intermediate, the formulation which we discussed earlier. It's an emulsion intermediate and kept in the same can or the similar storage container what we have for the alkyd enamels, and we have kept it at room temperature, so we did not observe any separation. But moment you try to give them rigorous testing conditions, so when you expose those same emulsion intermediates to hot box, you observe separation. So that implies that the emulsification of water with your resin and solvent is not done properly, and that is what we are promoting. Again, we are promoting this additive to make an emulsion intermediate, and that's the ideal way of adding water. So using the same emulsion intermediate for making the paint then also gives the similar results, that in the room temperature it remains stable, but in stability it goes for a toss. You try to you observe defects like flooding, floating, or separation, those kind of defects. Yeah, so to conclude, 410 gives Saurabh WB 410 shows comparable performance against competition, and the best way to use this product is to mix this product with water, whatever amount of water you want to add, and make that emulsion intermediate, and shake the container well before use. So some precautions are there, and then no effects or no significant effect on drying characteristics or gloss development when you switch from the existing chemistry to Saurabh WB 410. With this, I end my presentation and set everybody free for the evening. Thank you so much. Thank you.
Thank you so much, gentlemen. On that note, I would like to invite our convener Neerav Shah sir to please come and felicitate the gentleman, Mr. Saurabh Nikhare, on the stage. have a question? Okay, done.
Yes, yes, please.
हेलो
Yes, sir.
एक बात बताएं, इफ देर इज एल्किड अमीनो सिस्टम,
Yeah.
एल्किड अमीनो सिस्टम दैट इज स्टोरिंग,
Yeah.
उसमें कुछ मॉइस्चर आता हो, वी कैन यूज दिस प्रोडक्ट टू रिमूव दैट मॉइस्चर, इस वर्क एज ए स्क्वेंजनर और द मेक इट अमलगमेट.
No, it's not a moisture scavenger, sir. So
It is not that, but if moisture is there in the alkyd amino system, can it work to remove the moisture?
No.
No.
It doesn't function that way. It is solely designed for including the water in alkyd enamels, sir. Yeah. Thank you.